when you read the question, I think many of you are going to find it a bit troublesome to understand that what is going on. The balloon was still in its vertical climb only, it was not drifting, that is for sure. This is a fabulous question. Let's read what is going on here. Let's see how we can solve this question. So the answers were A and C, then C. C was, now it is talking about a situation, location of A and B is perpendicular to the line joining B and C. Okay, now we are talking about a situation like this. So in this question, let's read what the question says. It says a hot air balloon of constant ascent velocity. So it is to be noted here that the velocity given here is constant ascent velocity. It is rising up with a constant velocity, can be used to investigate wind velocities at various altitudes. Employing this idea, one day a hot air balloon was released at a distance of 100 meter, which is indicated by alphabet L, from a point where a telescope was installed to track the balloon. Since the wind velocity was almost zero up to a height of approximately 30 meter, okay, that day the balloon first rose upward, and then due to horizontal drift caused by the wind, it followed a plain curvilinear path. During continuous tracking of the balloon, the telescope has been rotated in a vertical plane without change in azimuth. The graph depicting how the angle of elevation varies with time does obtain is shown in the figure. Alright guys, so we have read the question. I hope you also have read the question. The question is, when you read the question, I think many of you are going to find it a bit troublesome to understand that what is going on, and some of you may also interpret that this is the trajectory followed by the balloon. Some of you may interpret it like this, but let me make it very clear, students. This is not the trajectory followed by the balloon. This is how the angle of elevation of the telescope change. Now, let me first clarify this line, because I am very sure, based on my experience, that student will find this line very confusing. Like, what is going on here? A vertical plane without change in azimuth. What does that mean? So it's something like that. This, if pen is this pen is the telescope, and it is pointing something. All right, and that something is going up. Okay, then it is simply increasing its angle of elevation, that is, this angle is increasing. Something to which this pen is pointing, that is going vertically up. So this will also keep on rotating like this, like this, like this, without rotating like this or rotating like this. That is what the question wants to say, that it maintains the plane, the vertical plane in which the telescope is rotating. That plane is maintained, that plane is not changing. This is what the line means. And let me also show you that what is happening in the physical world. What we have here is the graph. It is the graphical representation of the information. This is not the trajectory followed by the particle. Let me show you how the how the balloon, like what is happening here and how we are getting the graph. So these are the questions we want to answer about the situation described on the previous slide. Let us first understand that what is happening in the physical world. So let this be the ground. Let this be the ground. Okay, let this be the position where the telescope is installed, and let the balloon rise somewhere from here. Let's say the balloon is rising somewhere from here. So this distance is L. Okay, now as far as the trajectory of the balloon is concerned, the balloon first rose to 30 meter like this, and during this point, during this journey, the balloon was not experiencing any kind of drift because of the velocity, but after this it started experiencing the drift. Now the question doesn't tell us that in which direction the balloon is drifting, whether it is drifting like this or whether it is drifting like this. Okay, so we first have to figure out that whether this is correct, let's say option A, or whether option B. So guys, pay attention to this. If option A would have been correct, all right, then what would have happened? The telescope which would be here, the telescope which was, let's say, here, okay, that telescope would change its orientation like this, all right, and the angle will go on increasing, and the maximum angle that we are going to get will become 90 degree. Or you can say that if we are continuously plotting the angle beyond 90 also, it will go on increasing. It will it will go on increasing. Okay, but in this graph, we do not see a maximum of 90 in this situation. So how that graph is made, I have not made it clear yet. Let me make it clear. So as the balloon was rising, okay, let me change the color. As the balloon was rising, let's say balloon was here, then the telescope was pointed like this along this line. When the balloon reached here, the telescope was pointed along this line. All right, when the balloon was here, the telescope was pointed along this line. So you see that this angle is increasing. So it is this angle versus time, that is the graph that has been given to us. You can notice that this angle is increasing, and if this is the path followed by the balloon, then this angle will increase and it will attain 90 degrees also, or close to 90 degrees, which is not there in the graph. So we are very sure now that this is not the trajectory. So we are very sure now that B is the trajectory. So let us now redraw the figure with B as the trajectory. So again, this is the ground. Okay, the telescope is somewhere here. This is the telescope, it is somewhere here, and let's say the balloon is rising from this point. So it first goes vertically up, and then it starts going like this because of the drift of the wind. And you notice that during this, what happens is that the telescope points like this, then like this, then like this, then like this, then maybe like this, somewhere here, and then it again starts pointing. Like you see, do you notice how the angle increased to a maxima? It attained the maxima for which point? The point, like if I draw a tangent from this point onto the trajectory of the balloon, okay, then this is the point where we are going to get the maxima. So guys, this is the tangent, you know, that doesn't look like a tangent in my figure. Of course, that's because I'm doing it with free hand. So now this is the angle, okay, the angle increased and then it started decreasing. This versus time, this graph is given to us. Okay, now that is one thing. Now I want to check one thing. The question says that during first 30 meters there was no wind, so it kept on rising like this. So I want to know that by the time balloon reaches here, after starting its journey, by the time balloon reaches here, what would be the angle? So I want to know that. I can readily calculate that. Why I can readily calculate that? Because we have been given that this height is 30 meters. We have also been given that this distance was 100 meters. Okay, so this angle, okay, this angle, like the angle after which wind comes into play, let me call it as theta1. So tan of theta1 will be given by 30 by 100. Okay, now in solving these questions, guys, I will assume that we have enough knowledge, like we have tools to find out tan of such numbers also. I'm using a scientific calculator to do this. So I'm calculating tan inverse of 0.3. Alright, so that is around 17 degree. This is very close to 17 degree, like theta1 is very close to 17 degree. I'm getting 16.99 degrees. So 16.69 actually, yet we can assume it to be 17 degrees. Okay, now when I come back to this graph, I see that the graph begins from 15 degree. Do you notice that? The graph begins from 15 degrees, and we are also told that the angle of 15 degree was attained at a time of 3.3 minutes, after 3.35 minutes. So once the balloon started rising, all right, after 3.35 minutes, the angle was 15 degree, right? And we have already checked that it will start drifting after 17 minutes. So during this, like at this particular point, after 3.35 minutes, the balloon was still in its vertical climb only. It was not drifting, that is for sure. All right, which basically means that this distance is surely 100 meter. Okay, this distance, let us call it as y. We can surely calculate it using trigonometry. For example, we will write tan of 15 degree is equals to y by 100. So from here we can calculate the distance y. Let me again use the calculator for this. So that would be 100 tan 50. So 100 tan 15 degree will give me 26.795. Okay, and this is what, this is in meter, this is 100 meters, so y will also come in meter. So this much meter. So the balloon reached this height and it took 3.35 minutes to reach this. So what was the rate of climb, that is what was the ascent velocity of the balloon? Let me write it as v0. So what was the ascent velocity? I will write v0 to be the height risen, which is y, divided by the time it took, which is 3.35. So when I divide this with 3.35, okay, I get 7.99 meter per minute, which is as good as 8 meter per minute. So let us check the first question. I think the first question was around this only. Ascent velocity of the balloon is closest to, so out of these given options, 8 meter per second is the right choice. Okay, so that is one thing. Now next the question says wind velocity at the altitude of the balloon where the angle of elevation attains a maxima. So we want to know the wind velocity at the point where angle of elevation attained a maxima. So we have already discussed that the angle of elevation will attain a maxima when we draw a tangent from the telescope on the path of the balloon. Okay, let me do it on a blank slide. This slide is quite messy right now. So this is ground. Okay, this is the telescope. This is the trajectory. All right, so we are supposed to discover a tangent. Of course, guys, this screen is bigger for me to have the view to draw a proper tangent. I try to do my best. Okay, but if you are sitting on a table with scale in your hand, I think you can surely do that. In fact, we just need the okay, I messed up. We just need the concept. Like we don't really need to draw a nice figure drawn with scale. I think I did a good job. I think I did a fairly good job. Okay, so what we know right now is that this is a tangent. Okay, what we know is that this angle is 53 degree. How do we know that this angle is 53 degree? Well, we know it because it is given in this graph. This angle is 53 degree, so it is given here. We also know that it took 50 minutes It took 50 minutes to reach that point. Okay, no problems. 50 minutes. Now guys, here, if this green line depicts the trajectory of the balloon, can we say that right now the instantaneous velocity of the balloon will be along the tangent to the trajectory, which happens to overlap with the tangent drawn at this point from the telescope. All right, and this red arrow will actually represent the resultant of wind velocity and the vertical component of the velocity, which we have already calculated to be 8. We just did that. The vertical component V naught. Okay, we are calling it as V naught. So we can also say that tan of 53 degree. This is 53 degree. So this will also be 53 degree. Tan of 53, which is very close to 4 by 3. Okay, this would be equal to V naught by VW. And notice that we were supposed to find VW, the wind velocity at the point where the angle of elevation was maximum. So that's exactly what we were supposed to calculate. This is W. Okay, so wind velocity would be equal to 3 times of V naught. The value of V naught was 8 by 4. So that would be 6 meters per minute. So that would be the value of wind velocity. Let's go back and check whether we have 6 meters per minute as an option or not. So this is again the correct value. All right. So here option C was the answer. Here option B is the answer. All right. Horizontal drift of the balloon when the angle of elevation required. Easy question, guys. So this question is asking us to find out horizontal drift of the balloon. So the balloon started from here. Right now it is here. So let's call this drift as D. So this is the distance we want to find out. We already know that this distance is 100 meter. Okay, we don't know this height yet. We will calculate this height. Remember that balloon took 50 minutes to reach this point, and the balloon was rising at a constant rate of V naught. V naught was 8 meter per minute. So 8 meter per minute multiplied by 50 minutes. All right, so that's 400 meters. So this height is 400 meter. All right, we know that. We know this angle. We know we can calculate this length. We will get the value of D. So we are going to write 4 by 3, that is tan 53, is equals to 400 by 100 plus D. So this will give us 100 plus D is equals to 300. So the value of D would be 200 meters. Okay, the value of D would be 200 meters. So let's go back and check whether we have 200 meters as one of the options. So we do have that as one of the options. So the answer would be 200 meters. So that's how we solve this entire comprehension. So answer would be C, B, B. Let's check. C, B, B. That is the answer. I hope you enjoyed the question. I hope you enjoyed the solution, students. Okay, now fabulous question, guys. I must say this is a fabulous question. Let's read what is going on here. Let's see how we can solve this question. So the question says that there are two particles A and B, and they're moving towards each other on a straight line, okay, with equal speeds of 5 meters per second. Fine. At an instant that is assumed as t equals to 0, the distance between the particles is 100 meters. All right. It is desired to move another particle C, that always maintains a distance of 40 meters from the particle A and 30 meters from the particle B. Okay. And then we have some questions. Let's first, without reading the questions, let's first understand what is going on. Okay, so there are two particles which are separated by some distance, and they're moving on the same straight line. The particles are A and B. Okay, and now A and B, they're both moving with the same speed of 5 meters per second. So A is going with the speed of 5 meters per second, and B is also going with the speed of 5 meters per second. And at t equal to 0, or the moment which is considered as t is equals to 0 in the question, A and B were separated by 100 meters. Okay, now we have to start thinking from here. Particle C has been defined as a particle which is always at a distance of 40 meters from A and 30 meters from B. Let me just confirm whether I remember it correctly or not. So maintaining a distance of 40 meters from the particle A, all right, and 30 meters from B. So I want to know where is C particle right now. Okay, and if I think a bit, if I think of all the points which are at a distance of 40 meters from A right now, I would be thinking about a sphere of radius 40 meter around A with center at A. Think about this. And if I'm looking for points only in this plane, then instead of sphere, I will be thinking about a circle. Okay, so what I'm saying is that all points which are in this plane and at a distance of 40 meter from A can be found on a circle, the radius of which is 40 meter. All right, like this. Okay, so C point has to be somewhere on the circle. Likewise, C point, if I talk about all the points which are in this plane and at a distance of 30 meters from B, okay, then again it's a circle of radius 30 meter centered at B. All right, and students, you have to forgive me for my freehand drawing. For example, after drawing the circle, I can see that this point doesn't appear like the center of the circle, but please don't ignore all those things and focus on my words also, and then focus on the figure also. So B is the center. This circle has a radius of 30 meter. Okay, now guys, the farthest I can go from B in search of this point is 30 meter. The farthest I can go from A in search of this at this point towards B is 40 meter, and the distance between A and B currently is 100 meter. Again, the figure is not drawn to the scale, so don't think about this, that how come this small length is 40, this small length is 30, and like, so no, it doesn't match. Like in any case, it's a freehand drawing. Okay, so what I see right now is that C is non-existent as of now. C is non-existent as of now. I hope you agree with me that right now there is no point which can be said to be at 40 meter distance from A as well as 30 meter distance from B. It can either lie on this circle or it can either lie on this circle. Right now there is no overlap. But from this interpretation, from whatever we are interpreting here, if you start imagining, when will C come into being? When will C start existing? Think of this. So as A and B are moving closer, think about the corresponding circles. These are also moving closer. And the moment these circles start touching each other, can I say that would be the moment when C comes into existence? For example, after some time, we are surely going to have a situation where the circles will just touch each other. Okay, again, ignore the scale. Like, so let's say this is one circle, let's say this is another circle. The radius of this would be 40 meter and the radius of this would be 30 meter. Right now the distance between the centers of the circle, that is particles A and B, would be 70 meter. Okay, so the distance was initially 100. Okay, it is decreasing, and when this distance first time becomes 70, at that point C comes into existence. Alright, so at this very moment C is existing here. This is the point C. Okay, with further passage of time, let's say dt time after this, the circles will overlap. Right now they are just touching each other at one point. After this they will overlap, so there would be 2 points of points of intersection. You can consider any one of them as C. Alright, so after this, the situation that we will witness, again guys, we will solve the question, but first let's understand the entire situation. So after this we will see that A and B are overlapping. So the distance between A and B, this distance would be less than 70 now. Okay, it is less than 70 meters. So let's say the C point is existing here right now. The C point is existing here right now. Alright, the circles will keep coming closer. Okay, so this distance is 70, it is decreasing. Now guys, notice this thing, that once C comes into existence, this distance is always 40. That is what the question tells us. This distance is always 30. This distance is variable, but this distance AB, it forms the third side of the triangle ABC. So we can say that the situation demands that ABC will constitute a triangle such that the length of AC remains fixed at 40, the length of CB remains fixed at 30, the length AB changes. So guys, in a triangle where the length of two sides are 40 and 30, what is the maximum length that the third side can have? That is 70 meter. That was here. Okay, what is the minimum length that this side can have? So the minimum length would be 10 meter, the difference of these two numbers, that is the minimum length that they can have. Once the distance between them becomes less than 10, for example 9.9999, all right, at that very moment C again disappears. All right, so when will that happen? When will that happen? So in about some time, A will be here somewhere and B will be here somewhere. Okay, the distance between A and B will be 10 meters. Okay, the distance between A and B will be 10 meters. And right now, the two circles that I'm drawing, those circles, okay, those circles will simply touch each other. See, this would be the situation. Okay, so this larger one has a radius of 40. This is smaller one has a radius of 30. All right, and the distance between A and B is 10. At this very moment, the two circles will again stop touching each other. This would be the situation, the larger circle and the smaller circle. All right, this would be A and this would be B. The distance between them will become less than 10. This is less than 10. So C again loses its existence. All right, so C existed when the distance between A and B, okay, when AB changes from 70 meter to 10 meter. During this C existed, then C disappeared. Okay, we are here. Now, after how much time will C reappear? Like, will C reappear at all? So guys, you imagine this now. A and B were coming closer to each other. They were at a distance of 70. C came into being. They are at a distance of 10. C disappeared. They will cross each other, and then again the distance will become 10 after some time. Okay. Then C will again come into existence. This distance will again increase to 70 meter. C will again lose existence after this. So, so what I'm trying to suggest is that when AB distance is 70, okay, C appears. and then it stays till AB distance becomes 10. Okay, so all this while C was there. C disappears now. At this moment or slightly after this, C disappears. Okay, then what happens? A and B, they cross each other. C is non-existent right now. Then B comes here, A is here, B is moving like this, A is moving like this. The distance between them is again 10 meters. So C appears again. Okay, C appears again. And then B is here, A is here, B is going in this direction with 5 meters per second. C is going in A is going in this direction with 5 meters per second. The distance between them is 70. So at this moment, C again disappears and then C never comes back. Okay, so this was the duration when C existed and this was the duration when C existed. Once you have understood this, you can definitely do the math yourself. For example, the initial distance between A and B was 100. So after how much time the distance will become 70? That will happen after 3 seconds because the distance between them is decreasing at the rate of 10 meters per second. Alright, so this must be t equal to 3 seconds. Then the distance changed from 100 to 10. So 90 meters decreased. So that would have taken 9 seconds because in every 10 seconds, in every 1 second, 10 meters is decreasing. Okay, then what happened? 100 became 0 and then 0 became minus 10 or 10 in the other direction. So 100 and then 10, 110. So distance changed from 100 to 0 and then 10. That must have taken a total of 11 seconds. So this should have happened at 11 seconds. Okay, and then 100, 0, 70 again. So 100 to 0, that's 10 seconds. 0 to 70, that's 7 seconds. So this must have happened at 17 seconds. So what are the times when C will be there? 3 to 9 seconds and then 11 to 17 seconds. So let's see whether we have options like this or not. So when and for how long can the particle C fulfill the given condition? So 3 to 9 seconds is one of the answer and 11 to 17 seconds is the other answer. All right. Okay, students. So this we have addressed. Now, what is the next question that we have to solve here? The next question says that what is the speed of particle C at the instant t equal to 5? Now, that's a very interesting question, guys. That's a very tremendously interesting and I really loved it when I saw that. So, guys, if this is done, okay, I made a note of blank slides. Let me check. 1, 2, 3, 4, 5. Okay, I have enough blank slides. Okay, so the next question says that after 5 seconds, right? Was it? After 5 seconds, what will be the separation between A and B? That will be 50 meters. Okay, so if I draw the triangle ABC, do you see any speciality in this triangle, guys? This is A, this is B, and this is C. Okay, notice that this is 50, this is 40, this is 30. Is this the good old triangle that we all know? 30, 40, 50. This angle will be 90 degree, this angle will be 37 degree, this angle will be 53 degree. Right. Also notice that if the distance between A and C is not changing ever, all right, we can interpret the situation as if AC is a rod, AC is a rigid rod, all right, and CB is also a rigid rod, okay, which is pin jointed at C. So these are two rods which are pin jointed at C, and right now the distance between AB was 50. A is moving in this direction with 5 and B is moving in this direction with 5. We want to know the speed of C. So we have transformed the question now to this. There are two rigid rods which are pin jointed at C. We don't know the velocity of C, but the other ends of the rod, we know their velocities. A is moving with 5 meters per second in horizontal direction and B is also moving with 5 meters per second in horizontal direction. Now guys, notice that these two are perpendicular to each other, which is actually, which comes to our rescue actually, which helps us. It helps us out. Okay. It helps us out. How? I will tell you. See, in physics, if we don't know the direction and magnitude of any vector, which is the case with VC right now, we don't know the direction, we don't know the magnitude. What we do? We tend to assume two components which are mutually perpendicular as the unknown components, and then we try to find those values. So I will make my life easier by choosing one component along this direction, let me call it as V1, and choosing another component along this direction. So notice that these two components are rectangular components. They are already perpendicular to each other. This is the instantaneous velocity, and if I pay attention to AC is behaving like a rod, so I can use the rod constraints, which means velocity of A along AC, that would be 5 cos 37. This should be equal to velocity of C along AC. Now velocity of C along AC would be V2 plus component of v1 in this direction, which is 0 because v1 is perpendicular to AC. All right, so we directly got the value of v2. This is 5 cos 37 is 4 by 5, so this is 4 meter per second. Well, similarly, we will employ the same logic. BC is a rod. All right, so we can use the rod constant. So velocity of B along BC, that would be 5 cos 53. 5 cos 53 would be equal to velocity of C along BC. So that would be V1 plus component of V2, which would be 0 because V2 is perpendicular to BC. So we got the value of V1 from here. V1 will be equal to 5 into cos 53 is 3 by 5. So that would be 3 meter per second. Now you have the two rectangular components of velocity of C. Therefore, you can readily calculate VC as root of V1 square plus V2 square, which would be 5 meter per second. So the velocity of C at this moment would be 5 meter per second. So option C would be the correct answer. All right, getting this, everyone? Okay, now the question says, what is the modulus of acceleration of the particle at this? Okay, now we are again discussing the same instant. Okay, but now we want to know the acceleration of C, not the velocity of C. We've already found the velocity of C. Okay, let me go back here. Let me go back to the velocity figure. Okay, so we want to find out the acceleration of C right now. Okay, guys, so let me start by asking a question to you. Is A an inertial frame? In this question, whatever conditions are given, based on those conditions, if I think about point A, is that an inertial frame? Yes, of course, it is moving with a constant velocity, so it is an inertial frame, which basically means that acceleration of C from the frame of A would be same as acceleration of C from ground frame. All right, because A is an inertial frame, so it should be same. So when the question says that find out acceleration of C, it means that find acceleration of C in the ground frame, and we have argued now that it should be the same as acceleration of C when seen from A. So let us check how C will appear when we view it from A. Okay, so let me make the triangle again here. Okay, this is A, this is C, this is B. Okay, so C has a velocity, A has a velocity of 5 meter per second here, and C has a velocity in this direction. This was how much? This was V1. We calculated V1 as 3 meter. Okay, so this was 3 meter per second. Okay, and then it had a velocity in this direction, which was 4 meter per second. Okay, so that is the case. Now what I am planning to do, if I am viewing C from A, so in that frame, what I will do, I will subtract the velocity of A from these vectors. So, or in other words, I can just reverse velocity of A and I can add. So the resultant of these three will be the velocity of C as seen by A. Okay, I hope you are getting this. In the frame of A, A will be at rest, so this will be gone, and C will get an additional velocity which would be equal to minus VA. So we have to find out the resultant of these three vectors. Okay, so how do we do that? So let's do one thing. This angle was how much? This angle was 37, I believe. 37, right? This angle was 37. So even this angle would be 37. So let's break this 5 cos. So in this direction it would be 5 cos 37. So it would be 4 meter per second. In this direction it would be 5 sin 37, 3 by 5. So it would be 3 meter per second. All right. So we can remove now. Now we need to find out the resultant of this, and we can see that this 4 meter will get cancelled. So what we are concluding now is this, that A is at rest right now, and C appears to be going in this direction, which is perpendicular to the rod AC, and it appears to be going in this direction with a velocity of 3 plus 3, which is 6 meter per second. Okay, which is 6 meter per second. So if we ask A, what kind of motion do you see in C? A will say that C is moving around me in a circle of radius 40. Think about this. C always stays at a fixed distance from A. So if we ask A about the trajectory of C, A will say that the trajectory is circular and the radius of the circle is 40 meter. So according to A, C is moving on a circle of radius 40 meter. Okay, and at this very moment, the velocity of C was 6 meter per second according to A. So A will say that C has an acceleration in this direction. Okay, and this acceleration is 6 square by 40. Let me call this acceleration as A1, let's say. So A will say that C has an acceleration of 6 square by 40, that is V square by R. Will A not say anything about the acceleration in this direction? Well, A will say that, okay, C may have an acceleration in this direction. I'm not sure, I'm not aware how much that is, but whatever acceleration C has, this component is surely this much. Are you getting this, everyone? See, acceleration of C from ground and A frame is same. So if I'm sitting in A frame, that's also an inertial frame. So again, to calculate acceleration of C, I can choose to break its acceleration into two parts, one of which is this, the other one is this. okay, or maybe in this direction. I'm not sure in which direction it would be. Okay, so let's say A2 is in this direction. It can be in any direction. So from the frame of A, we can't comment on A2, but we certainly can comment on A1. A1 would be this much. Okay, now why? How do we solve for A2? See, A2, if A2 is perpendicular to AC, then A2 automatically becomes the acceleration towards B. So whatever we have done from the frame of A, we can do the same thing from the frame of B. If we go in the frame of B, okay, if we go in the frame of B, B comes to at rest, and what will be the velocity of A, of C? So C already had a velocity of 3 in this direction, 4 in this direction. We will subtract velocity of B from velocity of C. So we will add a vector of 5 meter per second in this direction. This angle was 53. So 5 cos 53 would be 3, and 5 sine 53 would be 4. We remove this. This 3 gets cancelled with this. This becomes 8. So again, the same argument. B says that I am at rest and C is going in this direction with a speed of 8 meter per second, and C always stays at a distance of 30 meter from B. So B will say that C is going in a circle of radius 30 meter. All right, and at this very moment, C will have an acceleration in this direction, which is, let's say, A2, which must be 8 square by 30, and B will say I can't comment on this acceleration A1, but we have already found out A1. All right, we already found out A1 as 6 square by 40. B has found out the acceleration as 8 square by 30. So what is, and both of them are inertial frames. All right, so in this frame we don't know A1, in this frame we don't know A2, but using two different frames, using this we have figured out the value of A1, using this we have figured out the value of A2, and therefore the overall acceleration of C would be root of 6 square, okay, 6 square by 40 plus 8 square by 30, and that should do the job. Let me finish the calculation and let us check. So 36 divided by 40, okay, and this adds with 64 divided by 30. All right, no, I messed up, guys. I messed up a little bit. This is A1 and A2. We have to square them up also. I forgot that part. Okay, we have to square them up also. So this is A1 square, A2 square. So let me now finish the calculation. Okay, so it would be 6 square divided by 1600. That is one number. The other number would be 8 square divided by 900. We add them up, we take the root, we get 2.31. Okay, so this number is 2.31 meter per second square. Okay, let's go back and check the options. So 2.3 we have here, so that would be the answer. All right, I hope you enjoyed the solution. I hope you liked the question, guys. It was a fabulous question. Personally, I also like this question very much. Okay, let us check the answers now. So the answers were A and C, then C. C was 5, so this we calculated this, and A, yeah. So we found all the correct answers. Okay, all right, students. I hope you like the question. Okay, now this question, at the instant when the line joining locations of A and B are perpendicular to the line joining. Okay, we have one more question in the same passage. I missed it. Okay, how come my team also missed it? Question 35 is not here. Okay, anyways, so it is related to the same question. Now it is talking about a situation, location of A and B is perpendicular to the line joining B and C. Okay, now we are talking about a situation like this. Okay, somewhat like this. This is A, this is B, this is C, this is 90 degrees. So check this, when the line joining locations of A and B is perpendicular to the line joining locations of B and C. Okay, what are the magnitudes of the velocity of C relative to A and B respectively? Okay, now it's a different instant, first of all. So till now whatever we have solved, that was for a different instant. This is for a different instant. So the velocity of C right now will not be the same as what we calculated earlier. Okay, so what are the velocities right now? So let's say A is having a velocity of 5 meter per second. Okay, B is also having a velocity of 5 meter per second. The question is asking us what are the magnitudes of velocity of C related to A and B respectively. So again, guys, we don't know in which direction C is going. Okay, but we do know that AC can be treated as a rod. Okay, and BC can also be treated as a rod. We don't know the direction and the magnitude of velocity of C. So what we do, we assume two random directions. Okay, so what are the two directions that we should choose? Okay, what are the two directions that we should choose? Let's say this distance would be, no, this distance is 40, this distance is 30, so this distance would be not be 50, it would be something else. Let me calculate how much that distance would be. It would be 1600 minus 900 root, so root of 700. So 10 root 7 would be this distance. Now the thing is that this angle is 90 degree. Let's say this angle is phi. So do we know the value of phi? Yes, we already know how much would be sine phi. Sine phi would be 3 by 4. We know how much would be cos phi. Cos phi would be 10 root 7 divided by 40. So that would be root 7 by 4. And similarly, if we need the value of tan phi, let's just write it down. We may or we may not need it. So that would be 3 by root 7. Okay, so sine cos tan we have written. Okay, now what we will do, I think fundamentally we will do the same thing. AC is a rod, rigid rod, CB is a rigid rod. Okay, so I will take velocity components of C. Okay, let us choose one component along this rod. Okay, let this be Vx, and the other component perpendicular to this rod, let it be Vy. Okay, so like this we have chosen. Now if this angle is phi, okay, if this angle is phi, then this angle is also phi, okay, and this angle is also phi. So I will write velocity of A along the rod as 5 cos phi. This should be same as Vx. This should be same as Vx. So Vx we know would be 5 into cos phi is root 7 by 4. So root 7 by 4. Check this. Is that okay, everyone? Okay. Now to find Vy, we will use the fact that Vb, velocity of B along this direction, is 0. Alright, so velocity of C along this direction should also be 0, which means Vx sine phi should be same as Vy cos phi, or in other words, Vy should be equal to Vx. We have calculated Vx, 5 root 7 by 4. Okay, that is Vx into tan phi. Okay, and how much is tan phi? Tan phi was 3 by root 7. So 3 by root 7 will give us 15 by 4 meter per second. So we have found out the value of Vx, we have found out the value of Vy. So essentially we can do anything now. The question is asking us velocity of C with respect to A, the magnitude of this. Okay, so what do we do? Velocity of C with respect to A. See, if I consider this direction as x and this direction as y, so I will write VA vector, velocity of A. I will write VA vector as 5 cos phi, okay, 5 cos phi I cap plus 5 sin phi j cap. So that's velocity of A actually. So I will put it with the minus sign. And velocity of C. Velocity of C would be again, see, Vx I cap plus Vy j cap. You can notice that this Vx will get cancelled because Vx was same as 5xy. Okay, so we will be left with Vy. Vy is how much? Vy is 15 by 4. Okay, 15 by 4 minus 5 sin phi. So 5 into sin phi. How much is sin phi? 3 by 4. So that's a 0. Okay, so velocity of C with respect to A is 0. Now velocity of, so we do have 0 in 2 of the options. Okay, now velocity of C with respect to B. Okay, how do we write that? So I can write velocity components of C. I can choose new x and y. Let's say this is the new x and this is the new y. So velocity of C along y was 0. C only had velocity along x. So how much is that? Like it would be Vx cos phi plus Vy sin phi minus 5. Do you get this, everyone? Okay, this C did not have any component in this direction. It only had component in this direction. So this minus 5. Okay, so we have to finish Vx cos phi. Let me do it on this page. How much was Vx? Vx was this. So Vx cos phi. Okay, let me do it here. Vx is 5 root 7 by 4 into cos phi. Cos phi is root 7 by 4 plus Vy. Vy is 15 by 4. Sin phi. Sin phi is 3 by 4. Minus 5, that's plus 5. So this becomes 35. This is 35 plus 45. 35 plus 45 by 4 into 4 plus 5. So that's 80 by 16. 5 plus 5, that's 10. Okay, so 0 and 10 Option B would be the answer as it is given here. Alright students, so I hope you enjoyed the solution. I hope you understood the solution. So again, this was the last question of the previous comprehension. Alright students.